Good morning. Once again, there really couldn't be much more appropriate song to sing before this lesson than what we just sang. This lesson, a series of lessons that I'm going to do is a short series. Last week was lesson number 1. It's designed to help us understand or to really get a feeling for how great God is, how amazing He is. And I am basing these lessons out of the book of Job. In Job, he and his friends are having a big discussion about why he's having such trouble and suffering and all that kind of stuff. And they all end up saying wrong stuff. Finally, God intervenes. And in Job chapter 38, after God has had about enough as he can take of this discussion, says, "Then the Lord answered Job out of the whirlwind and said, 'Who is this that darkens counsel by words without knowledge? Now prepare yourself like a man. I will question you, and you shall answer me. Where were you when I laid the foundations of the earth? Tell me, if you have any understanding. Who determined its measurements? Surely you know.'" These guys have been talking so much about, oh yeah, this is true, this, that, acting really overly wise. We talked about that a little bit in Ecclesiastes class. God says, "You guys don't know nothing. Where were you when I did all this?" So we're in this lesson about the God that we worship, and specifically God the designer. God is an incredible designer. We have a big argument going on, just like Job and his friends arguing about their things. Today they argue, does the creation tell us anything? Is there a designer, or did it all happen by accident? God, if he could, well, he could, if he chose to take any of us aside and say, "Listen, folks, I'm going to ask you questions and you're going to answer me. Where were you?" Anyway, God has a little chat with Job. He says, "Where were you when all this happened? Who is this that darkens the counsel by words without knowledge?" You guys are talking, you don't know what you're saying. "Prepare yourself like a man, and I will question you, and you shall answer me." Then the question, "Where were you when I laid the foundations of the earth?" And last week, I mentioned that God, in this discourse, he says, "Where were you when I did this? Where were you when I did that?" He mentions water in all of its forms. We looked at vapor last time, but there's also liquid and solid forms, which we're going to talk about today. God speaks about all three of these in Job 38. Like I said, last week it was vapor. And during that discussion, we talked about the hydrologic scale, how water evaporates, and by transpiration, evaporation, and sublimation, moisture gets up into the air, vapor gets up into the air, forms clouds, the clouds get blown around. They do things like swirling around all over the place and end up dumping that water out, and how that all the clouds in the sky, that changes every 9 days. All the water that's in the clouds right now, 9 days from now, will be on the ground or in rivers, lakes, whatever. Well, that was talk about vapor state. Today we're going to talk about the other two states. One is liquid form, water in not in vapor, not in clouds, but in liquid form. You see the different ways it's in liquid form. You got rain, you got dew, you got lake, you got oceans, and you got rivers, all the liquid form of water. That's what we're going to talk about first. One thing God said about water is, talk about the oceans. He said, "This far you may come." And this is in Job 38 also. "This far you may come, but no farther. Here your proud waves must stop." And so the first thing, God determines where water goes and where its limitations are, what it does. That's one of the things that he does. Next week, we're going to talk about the tides. and the currents of the ocean. And so I won't go any further into that, but God determines how far water can go. He also said in Job 38, have you entered the springs of the sea? Job, have you entered the springs of the sea? Do you even know they exist? Think about it. The springs of the sea are under water, and many of them way under water. How many people up until Job's time do you think had ever seen even one of those springs? You think any of them? How could they? They didn't have any diving equipment, but yet God, the writer of Job quotes God as saying, have you entered the springs of the sea? That's the evidence right there about the Bible, saying something that they didn't know. They couldn't possibly have known. And he says, were you there? Or he says also, or have you walked in search of the depths? Have you had a diving suit on and have you walked on the bottom of the ocean searching out the depths of the water? No, you haven't. Again, it's telling us that there's things down there that you could see. God also says, who has divided a channel for the overflowing water? And if you guys, did you do that? Did you make a place where the water has a channel that it goes down? Well, God can do that. This picture is one of those ways that water gets down to the ground. Rivers and streams are other channels that it works through. But for now, I want to turn to the oceans a little bit. Oceans are teeming with life. There's just billions, literally billions of sea creatures and plants that are growing under that you never would see unless one of those dolphins or whales happens to breach and come up out of the water. Otherwise, you would never see them, but they're all down there. It's teeming with life. In fact, over half of the Earth's oxygen is produced in the ocean. We talk about trees, how they breathe out oxygen and take in the carbon dioxide that we breathe out. More than half of it comes from the algae and the plants that are down in the ocean. Another good reason to care for the ocean, by the way, but more than half of the Earth's oxygen is produced in the ocean. 70% of the Earth's surface is covered in ocean. So way more than half, almost 3/4 of the whole surface of the Earth is ocean. Here's a thing we don't think about much, is fresh water. 90% of the Earth's fresh water comes from the oceans and the seas. Now, are the oceans and the seas, are they fresh water? No, they are not. But last week we learned about vapor. We learned about evaporation. And when water evaporates, guess where the salt stays? Stays down. It's pure fresh water that goes up into the clouds and gets blown over and rains on us. So we get fresh water. So even the salt water provides fresh water. 90% of all the Earth's fresh water comes from the oceans. I'm going to talk a minute about underground water. He talks about that. Have you searched the depths? Underground, there are 45 times as much water underground as in soil moisture, ground and ice, permafrost, lakes, the atmosphere, all the clouds, swamp water, rivers, and biological water combined. All of those, all the water that is in any kind of form, anywhere above ground, there's 45 times as much water beneath the ground that we walk on every day. That is an amazing thing to think about. God provides in ways that we can't even imagine. People question, where did the water come from for the flood? Well, if you put 45 times as much water as there is right now, where would the water level be? It'd be way over Mount Ararat, that's for sure. So anyway, science will tell you. I mean, these are scientific facts. Listen to the science, they say. Well, that's what science says. There's all that water down there. But will they admit that that water could be pumped back out again? And those springs in the sea could gush forth water and create a flood. Nobody, all the science, I should say all the science, most of the scientists won't admit that that is even a remote possibility. This is fresh water for mankind's use. It's down underground. We have examples all around. Getting water from under the ground. All the water that we drink comes from underground, from aquifers that are water that's under the ground. When I preached this lesson before, I talked about this farm near Animas, New Mexico, belongs to my niece and her husband. I don't remember how many thousand acres they have. As you can see, if you just look at it, you think, well, why would anybody want to own that? Other than you see the green spots there, but do you see any source of water in any of these pictures? They're all pictures of their place. Not a source of water on the surface anywhere. But they have pumps. And even though there's no surface anywhere, they have two wells pumping a total of 2,400 gallons per minute, 24 hours a day. That is a lot of water coming out of the desert of New Mexico. There's a river running underneath their property that's as big as the Mississippi River. And it runs out and dumps out into the Gulf of Mexico, way down underneath the surface of the sea. Incredible what God has made when he put this earth together. Okay, so that's one kind of water. Here's another kind. Biological water. What does that even mean? Well, here's what it means. Plants and animals are composed mostly of water. Humans are mostly water. A man is 65% water. That means 35% other stuff. Women are 60% water, 40% other stuff. The blood that's in your veins right now is 94% water. That's just amazing to think about. God has created water, and we're going to learn some more stuff about water that's totally amazing. But God created water, and without it, you know what would happen with us. If 94% of your blood went away, you'd be in a heap of trouble. The rest of it wouldn't even flow. So anyway, water is amazing and it's important. Water regulates the temperature of the human body. It carries nutrients and oxygen to cells. It cushions joints. It protects organs and tissues, and it removes wastes. All of these things are absolutely essential to your life, to human life. That's what water does. That's water in the liquid form. Now let's talk for a little bit about water in the solid state. Job 38, these verses talk about that. They say this: from whose womb comes the ice and the frost of heaven? Who gives birth? Who gives it birth? The waters harden like stone, and the surface of the deep is frozen. I wonder sometimes how, if they could have known about the surface of the deep being frozen, how many people do you think had gone up to the Arctic and learned this? There may have been a few that were explorers that did that, but it couldn't have been widespread knowledge. But yet the Bible mentions the ice covering the surface of the deep, the ocean. When it says the deep, it's always talked about the ocean. He also said, well, so we're talking about ice when we talk about water in its solid state. Here's some things about ice. One thing it does is it stores fresh water. 68.7% of the fresh water on the Earth's surface is in ice. You take all the rivers, all the streams, lakes, and everything, that's less than half of the fresh water that's above the ground. 68% of it is frozen in ice. That's water being stored for future use. Ice carves new shapes. You can read about it in your school books about glaciers forming and pushing down and making mountains and carving out rivers and all this kind of stuff. Ice is powerful. It has a reason. How do these piles of rock, oh, pardon me, there's one more thing. I think I need to go back. Water expands by 9% when it freezes. Water is one of the only liquids there is that expands when it freezes. Most of the time, everything contracts. That's what we're taught in school, and that's the truth. Things contract when they get colder, but not water. It expands when it freezes. That's why I put this next one up here. You all know these piles of rock that every time you go to Quincy or Spokane, you drive past them. There's columnar basalt, and you see at the bottom of these a pile of rocks. Where do those pile of rocks come from? Well, it comes from water getting in between these columns of basalt, and when it freezes, it expands and pushes those rocks apart and breaks them up. They end up falling into a pile at the bottom. That's because of the way water works. When it freezes, it accomplishes something just by that. But here's a really fascinating thing, and that is that ice floats. It doesn't sound fascinating, does it? But when you consider everything else, when it gets frozen, it gets more dense and sinks. If you freeze alcohol, it doesn't, alcohol cube, ice cube, doesn't stay on the top. It goes straight to the bottom because it contracts. It's more dense, not water. Water is the one thing that goes up when it gets cold enough. Here's the fact. Water above 34 degrees sinks. Even water sinks as it gets colder until it hits 34 degrees. After that, when it gets lower than 34 degrees, it rises. It's one of the only liquids that becomes less dense when it's frozen. And that's what causes ice to float. We're going to talk about what would happen if ice didn't float. Sea ice acts as a two-way insulator. Just picture this layer of ice. That's the white stuff up there. Above it in the Arctic area, it can be anywhere from 41 degrees above zero down to minus 40 or, even colder than that. When it's minus 40 above the sea, what do you think happens to the sea? It freezes, right? But as it freezes, it creates an insulation. And it only gets so thick. And then the water underneath, well, when water freezes, it's 32 degrees. It's actually a little colder than that, well, if it's salt water. But the interesting thing about that is, I think the next thing, well, it insulates water from the harsh temperatures above, from the minus 40 degrees, keeps the water from freezing all the way solid, but it also insulates the other way around. It insulates the ice from the warmer temperatures below. Down below, the currents, so we'll talk about next week, the currents flow northward and southward. Those warmer currents from the Arctic area or from the equator flow up and come underneath there, and they would easily melt all that ice, except here's what happens. Salt is released when water forms or when ice forms. The water that sits on top of the ocean, even though it's ocean water, it's fresh water because salt ions cannot be part of the crystal lattice that water forms when it becomes ice. And so salt is released as water freezes, and that makes the water right under the ice real salty. That one that's called the upper halocline layer, which is 35 or 34 to 35 degrees, that water is cold because the salt water sinks and leaves just the cold water above. And so it keeps the ice from melting right above. So there's a layer of insulation there. And then as it gets further down, the waters warm up and warm up. But just think about all the sea creatures that live under that ice. And if ice didn't float, if it went to the bottom every time it froze, what would happen? The ocean would be full of ice, at least in the northern parts. Any life that's down there would not be there. So ice actually protects the life underneath it. We've all seen videos of the whales and how they travel around, and much of the time they spend up there under the ice. And all kinds of other sea creatures do that. Like I was saying, the denser, saltier water, when salt comes out as ice freezes, it sinks down and I've already explained all this stuff, so I'm just going to skip on because time is running. But in the form of ice, water does some amazing things. Now, here's the snow part. In the form of snow, God said in Job 38, "Have you entered the treasury of snow?" I'm sure they were familiar with snow, uh, even in the areas where they lived where there wasn't snow all the time. They knew about snow. That's the only way they could get anything cold was to get snow or ice and bring it down from the mountains. But anyway, let's talk about snow. Snow provides temporary storage for fresh water. We know all about that. We need the snow up in the Cascade Mountains in order for us to have water in the summer because it stores water and trickles it down slowly so that we have water running in the rivers and streams year round. They don't dry up because there's no moisture anywhere to be added to them. So they store fresh water. Snow also insulates from extreme temperatures. That picture right there, they look like pillars of salt, but really it's snow. And guess what's underneath each one? Trees. If it wasn't for that snow around the trees, what would happen to them? They would freeze and die because the temperatures get extreme in places where they could not possibly survive. But wherever ice is, what's underneath the ice is never more than 32 degrees. And so even with, I don't know if they do it around here or not, but down south with the citrus stuff, if there's going to be a frost, they turn sprinklers on and put water all over it. You think, why would you do that? Why would you freeze it? And that's because ice only can go down to 32 degrees. And so if it's 10 below, those plants are still only 32 degrees. So it's incredible. It's amazing how snow and ice work. Snowflakes, something that Job probably knew nothing about. They're incredible. They demonstrate the intricacy of God's creation. You've all heard there's no two snowflakes alike. They start off from each one from a different shape, a piece of dust or something floating in the air, and the water molecules add to it, and it's always six-sided. they're all different, but they're always six-sided because that the crystal lattice of water, that's how the molecular structure works. But it forms some beautiful, beautiful things. And they demonstrate. I mean, here's a little thing that until we got microscopes, we couldn't even see this, but it's just one of God's ways of showing how incredibly wise, what a designer, what does it take to make that? Then he says, or have you seen the treasury of hail? He mentions hail as well. Hail, we don't have a lot of good things to say about it, but there are some good things, and I'll say it in just a minute. But the way hail forms is the warm air that you see in the red there goes up. Warm air rises, it goes up, gets into the clouds where it's colder and colder. You see the temperature range up there at the very tops of clouds. It's 58 degrees below to 48 degrees below, or pardon me, 58 to 94 degrees below zero at the tops of the clouds. In the middle of the clouds, it's 40 to 76 degrees below zero. And then down in almost in the lower half part of the clouds, it's where it's freezing or a little bit above freezing. But anyway, that blue line is the freezing part. And as a warm air rises, it takes water molecules with it and puts them up, and they start freezing. And they freeze and get so high, and they drop down, and then the warm air blows them back up again, and it goes in a circle and a circle. Every time it goes up, it adds a little bit more water, a little bit more water, and these tiny little crystals become bigger and bigger and bigger till sometimes they're baseball size of hail. And the baseball size ones can be pretty damaging, but it's this cycle that happens, an incredible cycle that God invented to make this all work. This can't happen by accident. All this stuff that happens with water, it's not an accident. Just another way of looking at it. You can see the shape of the blue dotted line there, how it follows the warm air up and then curves back down and then gets blown back up again. And I think I put in here. Oh, I guess I didn't. Um, anyway, it circles and circles and circles. But like I said, hail can be beneficial. It can break up dry soil crust. Anybody that's ever walked out into a wheat field in Montana uh, during most times of the year, it's a hard crust across the top. And that can't absorb anywhere near as much water as if it's broken up. Hail can do that. Hail adds moisture in a time release kind of fashion. Anybody that's lived in the desert knows that when it rains, it rains. And when it rains hard, most of the water runs off without even doing any good to the land it's getting rained on. But with hail, it stays in the form of ice and melts slowly, gives it a chance to soak in. So that's something that hail can do. It also cools overheated plants. It hails a lot in those areas where it's hot. And that's how hail forms, is when there's a hot air going up and blowing the moisture up into the cold parts of the clouds. When it falls as hail, when it becomes big enough and falls down out of hail, it can cool plants that it falls on right in a time when they really need it. It also can knock pests off of leaves. I think that sounds funny, but it can. We all know that it can knock branches off of trees. It can certainly knock pests off of leaves. It helps the atmosphere balance heat vertically so that the whole Earth system stays in balance temperature-wise. We don't have time to talk about all the effects of what would happen if there wasn't this balance, but hail is also part of the storm's electrical engine. We'll talk about that in a second. It is the major cause of lightning. You think, how does lightning happen? It happens because hail stones, as they bounce around, going up and around in circles, they bounce off of each other. And when they do, electrons, uh, negative electrons get broken off and collect and collect and collect. And when there's enough negative electrons up there, all of a sudden there's enough power to connect with the positive ions down on the ground, and you get lightning. Job says, or a path for the thunderbolt. Have you made a path for the thunderbolt? No, but God has. This is what a thunderbolt looks like. That's what we call lightning. And the way that it happens is the updraft from the warm air and the downdraft from the cold air, the swirling action, the ice crystals bouncing off each other, creating all these, I think I said it backwards earlier, creates the positive ions, and the ground is the negative. That's why we call it ground when you're talking electricity. Anyway, when it gets enough positive ions up there, then a lightning strike will happen. Well, that's where I put the swirls. Well, I thought I had. Let's try this. Okay. I knew there was sorts of swirls in there someplace. Anyway, it swirls around, creates all these positive ions. And then what you get is this. This is one of the most beautiful pictures I've ever seen. I'm sure it's a time lapse. It didn't happen all at once. But think about that. Lightning is striking somewhere on Earth at any given moment, right now. You blink your eyes and lightning has just struck. In fact, lightning strikes 40 to 50 times every second, somewhere on Earth. At any given time, lightning is striking 40 to 50 times per second. Constant flow of electricity from the sky to the Earth. There's an electrical system, obviously, that's happening. 3 million strikes per day happen every single day. Now, why does this constant lightning matter? It's not just noise and light. It keeps the Earth functioning. Lightning maintains the global electrical circuit. If there wasn't lightning, those positive ions would stay up there, and then everything would be totally out of balance. It maintains the electrical circuit. It helps create nitrogen compounds that fertilize soil. Now that sounds really weird. When lightning strikes, the heat from the lightning separates the chemicals in the sky and takes the nitrogen out of it, which falls with the rain, and puts nitrogen back in the ground. And we may add more nitrogen, but without lightning, you would definitely have to add more and more nitrogen. Another thing it does is it drives atmospheric chemistry. By ionizing, making this plasma that comes down, chemical things happen as a process, and the atmosphere changes because of lightning. Lightning sends electromagnetic waves into the ionosphere and the magnetosphere. Big words, but they're part of the layers of our atmosphere up there. And up there in the ionosphere and the magnetosphere is a thing called plasma, which is a kind of another form besides liquid, solid, and gas, which is something else that's way deeper than me. But you have to have this plasma is circling the Earth, and part of what it does is filters the sunlight from hurting us. And we've heard about the ozone layer and that kind of stuff. Lightning has a really important part. Well, all this is just the tip of the iceberg. Now, that's a joke, people. We've just been talking about ice. Well, this is just a tip of the iceberg of God's design and his wisdom. This is just water. That's all we're talking about. It's just water. And yet, all the things that we've learned about water, and we're not even done yet. We're going to talk about some more stuff about water next week, but it just shows us God as a designer. It's an intricate and immense system that he has made just in the water cycle. Incredible. All the way from the huge thunderstorms and tornadoes and hurricanes down to the tiniest little snowflake. Every one of it is design. What a system. God that we worship conceived, designed, and created it. We, it shouts out his wisdom and his loving care for his people. We should be proud to say, I am a believer in God. He did all this stuff. Instead of trying to apologize to people for or feeling, oh, they're smarter than me, they try to make you feel dumb, but you're the smart one when you believe all this evidence that's around you. Well, bringing this lesson to an end, just as intricate and unique as this snowflake is God's plan for our salvation. God planned this before he ever started creating the heavens and the earth. He created a plan to give man a free will and then to forgive him if he doesn't act properly with that free will. That's love in ways that we can't even begin to imagine. But all the stuff that he worked together to bring this about is incredible. All you have to do is read your Bible and look for it. There's so many things that had to happen in order for things to come out the way they did when Jesus was hung on the cross to die for our sins. That was a plan that God made. He made the earth for us. All the many wonderful things about it. It keeps us alive, but it also keeps us totally amazed when we look around us. If we look around us at the plan that God made, we should be amazed too, and to be happy that we're part of that plan. And if you're not part of that plan, if you have not been baptized into Christ, there's no more reason in the world stronger than these evidences that we've been talking about God and who he is and what he wants from us. If you haven't obeyed the gospel, time is now.